Okay, so for these types of questions, remember that the first thing we want to do is draw just a rough sketch of the heating curve of water and identify our starting and ending points on there. So we are starting with ice at minus 17 degrees, and we are headed for steam at 100 degrees. Okay, so that means I first have to heat the ice to 0. That'll be step 1. Then I need to melt the ice. That'll be step 2. I need to heat the water. That will be step 3. Then I need to vaporize the water in step 4. There is no 5th step because once I get the water vaporized, I have steam at 100 degrees Celsius. So I'm not ever heating the steam in this question. So there are only 4 steps. Okay, in step 1, okay, I am changing the temperature of the ice. What formula do I use? E equals mc delta T. All right, so for this one, that will be 1,500 grams, okay, times the specific heat of ice, 2.116, times 17 degrees. Okay, then in step 2, I need to melt the ice. So that'll be E equals MLF. Okay, so that's going to be 1,500 grams times 333 joules per gram. Okay, then I will have liquid water at 0 degrees Celsius, and I need to change its temperature. So what formula will I use? E equals mc delta T. Okay, and so that's going to mean 1,500 grams times now 4.2 because we're dealing with liquid water, and I'm changing it by 100 degrees. Okay, and then last step, I need to vaporize the water, so that'll be E equals MLV, and that'll be 1,500 times 2,260 joules per gram. Okay, so that's our 4 steps. Okay. So we'll have 1,500 times 2.116 times 17 plus 1,500 times 333 plus 1,500 times 4.2 times 100 plus 1,500 times 2260. Okay, so 4,573,458 joules would be required to completely evaporate 1.5 liters of water from ice at minus 17. Okay. All right, is that ringing a bell and making some sense? You will be asked to do that on Wednesday for sure. There is a heating curve of water question on the unit exam. Okay, moving on from there. Last topic. Biomes. Okay. All right. So, you're really best to follow along with the notes package. I have to go way too fast for you to write stuff down. Okay, like every single slide, if you're trying to write down what's on every slide, you're never going to get it done. Okay, because I'm going to go really fast on this. What you need to be able to do with the stuff you learned today is as follows. Okay, actually, let me tell you what a biome is first, then I'll tell you what that is. So a biome is an ecological region. Okay, it has very characteristic plants and animals and things like that. So a biome is an ecological region on Earth. The tropical rainforest is a biome. The Arctic tundra is a biome. Okay, things like that. So areas that have kind of distinctive features and characteristics. What you will be expected to do with the information in this lesson is twofold. One is if I gave you a picture and a description, you would be able to tell me what biome is being talked about. Okay? Pretty straightforward. Second thing, I give you a climatogram. You tell me what biome it fits with. Okay, so there's a little more analysis in the second one. The first one's basically just recall, okay? But the climatogram, that's a little bit more analysis for you. That means you have to look at the look at the climatogram and figure out where is this climatogram likely located, what kind of weather is being shown here, and then match that up with what you remember from the descriptions of the different biomes. Okay, so if I saw a climatogram that was, had a really steep bell curve, that was very low, the maximum temperature barely got above 0 in the warmest months, and there was not a lot of precipitation, I would probably say that would be like the Arctic tundra or the extreme desert or something like that, okay, I definitely wouldn't write tropical rainforest. Okay, so with that climatogram, you're going to have to not only identify what biome it goes with, but explain your reasoning. So in a question like that, you would tell me, first off, here's what the climatogram says. The weather here looks like this. That goes with this biome because in this biome, blah, blah, blah. Okay, so there'd be some explanation and go on. It would definitely be a written response question. Okay, for the identifying the biome from a picture and a description, that'll be a multiple choice question. There'll be a picture, there'll be a description. Is it A, B, C, or D? Okay. Okay. So, now we're done with that. Okay, so here are the various biomes of the world, okay, and where they are located on Earth. So the first one we're going to talk about is the tropical rainforest. That's this greenish color here. Okay, and you can see that the tropical rainforest is always near where? Yeah, always near the equator. You'd never see a tropical rainforest outside of 30 degrees north or south latitude of the equator, right? Because they simply would not get enough solar energy. It wouldn't be warm enough. Okay, all of that kind of stuff. You don't see tropical rainforests outside of the tropics, hence the name. Okay. So we see a lot of that in South America. Okay, obviously that's like the Amazon rainforest. So in Brazil and Colombia and Ecuador and places like that. Okay, there's also some in Central America. Okay, and some over here in the Caribbean. Okay, also some in Africa. Okay, in like the Horn of Africa here, okay, over on the eastern edge of Africa, and then almost all of Southeast Asia. So this would be like Vietnam and Laos and southern China and places like that. Okay, all tropical rainforest. And then over here, okay, you've got like Papua New Guinea, the Philippines, those kind of places, all very tropical places. All right, so we see a lot of tropical rainforest there. Okay, and a tiny little bit, okay, maybe on the northern edges of Australia. Okay. Well, if it's tropical rainforest, it might still be there. That might be the part of this continent that is wet. Okay. Obviously, the rest of it is not, and that's why they're having so much trouble there right now. Okay. The next biome we'll talk about after that is the savanna. Okay, and the savanna is what you would typically identify with Africa. Okay, it's the big grasslands with the lions and tigers, but no bears, and like elephants and wildebeest and stuff like that. Okay, so you can see the bulk of Africa, okay, is going to be that savanna type area. There's also a little bit in South America, but a lot of this is human produced, okay, as a result of deforestation in the tropical rainforest. Okay, and then there's some obviously in Australia. Okay, but again, it's very much a tropical type of climate. You do not see it necessarily, except maybe here along the Andes, that you would see it outside of the tropical areas. Now, desert. Desert can be misleading because there are different kinds of deserts. Okay, you can have a tropical desert, like the Sahara. So here along North Africa, okay, that would be a tropical hot desert. But there can also be mid-latitude deserts. Arizona, okay, is a mid-latitude desert. They get winter in Arizona. I mean, Phoenix is pretty nice most of the year, but if you go to like Flagstaff, they have a ski hill there, right? It's still desert. Deserts are defined by not necessarily their temperature, but their or lack thereof. Yeah, okay, the lack of precipitation. What makes it desert is it's really dry. Okay, we also see one right here. Okay, this one right here. Okay, this is a rain shadow desert. Okay, because what's right here? What's this white line with the blue around it? That's the Himalayas. Okay, this is the Gobi Desert. Okay, it's in like Mongolia. Okay, rain and stuff just doesn't get over the Himalayas. We got a tropical rainforest on one side. Okay, and on the other side we got a desert. Okay, and the reason for that is the Himalayas are really, really tall. Okay, and as a result, precipitation just does not get over them to the other side. Okay, this is not a warm desert. This is actually a very cold desert. Okay, you go to places, looking at places like Afghanistan and stuff like that. Okay, also very cold type desert places. Okay, and then obviously we got some in Mexico, Southern California, Baja, those kind of areas, and unfortunately, okay, Central Australia, the outback of Australia, okay, is all desert and very, very dry, and obviously that's why they're having all the wildfires there right now. Okay, so desert can be located in a lot of different places. Now, the other kind of desert is extreme deserts. And as you can see here, it says rocks and ice. right? So rocks and ice would be like a glacial type desert. Okay, the driest continent on Earth is what? Is Antarctica. Okay, they get less precipitation in Antarctica than anywhere else. Okay, but it's all frozen. And people have a hard time imagining Antarctica as being dry because it's covered in what? Yeah, in ice, really. Okay, it doesn't snow often there, but it's been locked down at the bottom of the planet for so long that all of the snowfall that has actually happened there has just not been able to melt, and it's just accumulated into those big ice sheets. Okay, but they actually get very little precipitation there. Now, extreme desert is also what you're going to see at the tops of very high mountain ranges. Okay, it's going to be very dry there. Even if they do get precipitation, is there any liquid water? No. Okay, that still makes it very dry. Okay, so you're not going to see a lot of plant life there, things like that in those types of areas. Okay, then we have this brown color here called chaparral. Okay, it's also called Mediterranean climate. I can't imagine why it would be called the Mediterranean climate, being as it's almost all entirely here in the Mediterranean. Okay, there's a tiny bit here at the tip of southern Africa. Okay, a little bit, you could kind of say southern California might be a little bit like that. Okay, and a tiny little bit on Australia, but I mean the bulk of the Mediterranean climate is around the Mediterranean, obviously. Okay, so if you've ever been to Greece or Italy or places like that, that's the Mediterranean climate. Hot summers. Okay, it's kind of drier. You've got like lots of different types of plant life, like olive trees and like grape orchards and things like that. Okay, so very different type of climate. All right, temperate grasslands. Okay, temperate grasslands are commonly known by their name that we call them, prairies. Okay, in North America we call the temperate grassland the prairies. In Asia they call it steppe. Okay, S-T-E-P-P-E. Okay, but it's basically the same thing. A grassland in Asia looks the same as a grassland in North America. Okay, it's just prairie. Okay. Temperate deciduous forest. What does deciduous mean? It's leafy, and they lose their leaves. Okay, so they shed their leaves every winter. Right. So obviously, much of the eastern United States and southeastern Canada, okay, would be around around the Great Lakes and stuff is deciduous forest, maple trees, okay, oak and magnolias and stuff like that. Okay, would live in that area. Okay, much of Europe, at least at one time, would have been temperate deciduous forest. There was a lot of clear cutting during the Industrial Revolution that's kind of changed that a bit, but okay, it would certainly have been that naturally. But that's typically the places where you see that biome. Okay, a little bit here, okay, on the kind of Asia as well. Okay, but for the bulk of it, it's Europe and the eastern part of North America. Okay, the taiga is very much a Canadian and North Asian biome. Okay, if you've been to Fort McMurray or Grand Prairie, you were in the taiga. Okay, if you've gone to Banff, you were in the alpine taiga. Okay, it's where there's like a carpet of spruce trees. Right, and that's all you see. That's the taiga. Okay, it's an important biome. There's a lot of natural resources obviously available in that biome, but it's also very rugged. Okay, and hard to urbanize and things like that. So you typically see it as one of the more undisturbed kind of places on Earth. Okay, and you can see that much of Russia is taiga, okay, and also much of Canada is taiga. All right, and then above that is the tundra. Okay, there's two types of tundra as well, alpine and Arctic. Okay, the Arctic tundra is what you'd see in obviously the high Arctic, but you also see it above the tree line in the mountains. Okay, so whenever you look at the mountains, the bottom of them are dark and the top are lighter. Okay, above that, that's the tree line. Okay, above that is the the alpine tundra. It's basically like a high altitude or high Arctic grassland. Okay, it's too cold for trees to become established. It's actually temperature that determines where the tree line is. Okay, not altitude. Okay, the further south you go, the higher the tree line gets. Right, the further north you go, the lower the tree line gets. It's all based on temperature, not on altitude. Okay, all right, those kind of make sense. All right, so we're going to talk about each of those in detail here. That's what kind of takes the longest part of this, is me going over each one of them, okay, in detail. All right, so we'll start out with the tropical rainforest. Okay, anyone ever been somewhere where there's a tropical rainforest? Okay, cool. Tropical rainforests are so different than forests in Canada. Okay, if you've only ever experienced forests in Canada, the first time you experience a tropical rainforest, it will be suffocating. Okay, because in a forest in Canada, you can walk between the trees. Okay, there's lots of space. You can actually see fairly far when you're in it. Okay, the tropical rainforest closes in around you. All right, it is just thick and it's hot and it's lush. Okay, it's very much different than a Canadian forest or a North American forest where the trees are more widely spaced and there isn't as much undergrowth. Okay, there are layers and layers of vegetation in the tropical rainforest. Okay, so it's very different in terms of its construction and structure. Okay, what you see here is only the top layer, which is known as the canopy. Okay, I call it a canopy because it literally covers the entire thing. Okay, it acts like an umbrella almost for everything underneath. Okay, these trees can be very tall. Okay, sometimes 100 meters or more. Okay, and obviously they do not shed their leaves. Okay, this is a tropical area where seasonality is not an issue. Okay, so general characteristics. Tropical rainforests cover about 13% of the Earth's land surface. They're complex and they're variable. That means there's lots of different types of plants. Okay, unlike in a Canadian forest where you could count the number of trees, the number of different kinds of trees on one hand. Okay, you're going to have Douglas fir, lodgepole pine, Engelmann spruce, black spruce, and maybe white spruce. Oh, done. Okay, yeah. All right, so they're very, very different in that way. Okay, they grow in areas with no distinct seasonality. That means there's no winter or summer. So a climatogram, okay, for a tropical rainforest would have a temperature line that's basically a straight line. It's not going to change very much, and the precipitation is going to be very high and pretty steady. You do occasionally get a tropical rainforest where you have like a rainy season and a dry season. Okay, that would be like torrential flooding here, but it's drier than the wet season or monsoon season. Okay, but typically you're looking at high amounts of rainfall, 200 millimeters or more. Okay, that's 20 centimeters of rain per month. Okay, that's a lot.
Didn't Calgary flood like 11 or something like that?
It was 17 over 3 weeks. Yeah. Okay. Yeah, 17 centimeters over 3 weeks. Now, granted, the worst part of that was it happened right when runoff was going on. That's why, when we get flooding, it's always the end of June. Okay, because if it rains a lot then, it combines with the snow melt, and that's what brings the rivers out. In a place like this, it's just steady. All right, now, the big thing about tropical rainforests, you can see in these pictures here, there's no tree line. Okay, the mountains look like a chia pet. Okay, if you've ever seen one of those. The stuff just grows over every surface. Okay, you would never see plants growing on a steep mountainside like this in Canada because the water would run off and it would always be dry and there'd be no soil. Okay, here, because it rains so much, the plants can actually grow right on all the really steep sides of the mountains, okay, with no problem at all. All right, so the other thing you can see is there's lots of different colors here, indicating lots of different types of trees and vegetation. Right? Again, something you don't see as much in a Canadian forest. All right, precipitation exceeds evaporation and transpiration. So that means more water falls on the area than evaporates. That leads to flooding, okay, and luxuriant vegetation. Now, soils in the tropical rainforest. This is counterintuitive. You would think to have all these big, luxurious plants and trees and whatever, that there would have to be really thick soil to sustain them. Actually, the exact opposite. Okay? Because tropical rainforests are typically so often flooded, the topsoil erodes and washes away. Okay? So typically, the plants grow out of the B horizon, the clayish part that doesn't wash away as easily. Okay? They just use their roots for anchors. They actually take most of their nutrients from the floodwater. Right, so they're constantly supplied with this water, okay, and they can pull the nutrients out of it. The soil is typically leached. Okay, now that word means exactly what it sounds like. It means the nutrients are sucked out of it. Okay, like a leech sucks your blood. Okay, this leaching process, actually what happens is you get water sitting on top of the soil, and the soil beneath becomes saturated. Now, because the water on top is moving, new water is always coming in. So the concentration of salts and nutrients in the soil is higher than it is in the water. So by osmosis, those nutrients are pulled out of the soil into the water and then they run off. Okay, so the soils are really, really poor, okay, in terms of their nutrient value. Okay, that's why in the tropical rainforest, slash and burn agriculture is such a problem. Okay, the only way for people to get enough food to survive is by agriculture. So they cut down the forest, they burn it, and then they plant their crops. But the soil is so nutrient poor that after 1 or 2 seasons, there's just no nutrients left in it. They can't grow anything anymore. So they go and they slash and burn another area. Okay? Now, we're not saying anything like people that do this are dumb. They're trying to live. Okay? They're trying to make food. Okay? This is what they have to do to survive. It's unfortunate though, because obviously the soils are just not good for agriculture, okay, in an area like this. Okay, decomposition is incredibly rapid. Okay, so if something dies in the tropical rainforest, it will be gone in weeks, a matter of weeks, maybe less, right? There's lots of insects, there's lots of bacteria, there's lots of fungus, all those things that can survive well in a hot, kind of moist area. Okay, those things are there. They're going to cause decomposition to be rapid. Okay, up here, a tree falls in the forest, it makes a sound, and it lays there for 50, 60 years before it's completely decomposed. Okay, because for half the year, it's frozen, and no decomposition can occur. Okay, the number of insects available to work on it is limited. They can only work on it when it's warm. Okay, fungus and things like that are much less prevalent, so they work a lot more slowly. Okay, like we said, intense weathering or erosion caused by high rainfall removes all the soil nutrients, and the soils are often low in calcium and potassium because those are highly soluble and they're the first things that are leached from the soil. Okay, so a soil horizon or soil profile in the tropical rainforest has an incredibly thin or absent A horizon, so very little topsoil, a very thick B horizon, and the bedrock is often quite deep. Okay, so there's a lot of clay, okay, kind of deposited from the floodwaters because it sinks very quickly. Right, so that's typically what you would have there. Okay, the vegetation in the tropical rainforest. Okay, tropical rainforests have extremely diverse vegetation in both species composition and structure. There are often up to 8 different layers of vegetation from the forest floor to the upper canopy. So there's like the canopy, the sub-canopy, the lower canopy, and then there's like the mid-growth, and all, like there's tons of different layers because there's so much available nutrients and energy there. Okay, there can also be up to 100 different tree types per hectare. Okay, now to give you an idea, a hectare is an area 100 meters by 100 meters. Okay, it's roughly the area enclosed by our running track out back here. Okay, that's roughly 1 hectare. 100 different kinds of trees. In a Canadian forest, there might be 100 trees, period. Okay? There could be 100 different kinds of trees, thousands of them, in an area that big, okay, in a tropical rainforest. So very, very dense and very, very diverse. Okay? All right. This is what tropical rainforest looks like at ground level. Okay? Very different. Like I said, you feel like suffocated or claustrophobic compared to a Canadian forest, okay, just because there's so much undergrowth. This is why you see people in the tropical rainforest carry machetes. Okay, that's the only way you'll A, get around, and B, find your way back. Right? If you just walk into this, and I learned this the hard way, okay, if you just walk into this thinking you're going to go for a little hike in the tropical rainforest, you'll get turned around so quickly. Okay, you can't tell what direction you're going anymore. You can't tell where you've been. It's hard to see your footprints because you're walking on plants all the time. Okay, not necessarily on the dirt. Okay, it's not like being in a forest in Canada. Okay, I don't worry about taking a compass or a map when I go with me out here. Okay, I can look up and know. Okay, well that way is south, that way is north. I can see the sun. Okay, I can see where I'm going. I get a sense of where I am. That doesn't happen in the rainforest. Okay, you can get very easily turned around. The vegetation is so thick that you can't see the sun, so you can't tell which way is north or south or east or west. Okay, it's very, very easy to get lost. Okay, so you want to have a machete so you can follow your path of destruction back. Okay, that's really about the only way. Okay, fauna. So that's the animals. Okay, the animals that live in the tropical rainforest. There's lots of them, but none of them are overly large. Okay, the tropical rainforest is not a place where you're going to find large predators. Okay, the idea that the lion is the king of the jungle is a fallacy. Okay, lions don't live in the jungle. Right? Everything lives in the trees in the jungle. Okay, and lions can't climb trees. Okay, so it doesn't. That's not where they live. Okay, so the bulk of the animal life in the tropical rainforest is bugs. If you don't like bugs, don't go somewhere for a holiday that has tropical rainforest. You'll not have a good time. Okay, because there'll be bugs everywhere. Okay, lots of times you'll sleep with a mosquito net around your bed. Okay, because there's so many bugs. Okay, and some of them are really big and ugly, like this, like this dung beetle. Yeah, that's right. It's a dung beetle. As part of their mating process, they make a big ball of poop, and they like roll it around to impress the females. Hey guys, don't do that. They won't be impressed. Taking a big ball of poop and pushing it around is not going to impress anybody. But if you're a dung beetle, it's big. Okay? Yeah, it's just a little weird. Okay, we're not dung beetles. Do not make a big pile of poop. It will not impress us. Okay. You can also have things like the walking stick. Anyone seen the walking stick before? Okay, they are incredibly well camouflaged. They look like a stick. Okay, like if you ever have one that if they like are crawling on you, okay, and they're just hanging there, if you blow on them, they actually will sway, just like a branch would on a tree. Okay, they're incredibly well adapted to camouflage. Okay, you're also going to have some brightly colored and sometimes highly poisonous reptiles. Okay, and lizards and things like that in the tropical rainforest. Obviously, they require water to reproduce, so they're frogs and things like that are going to be quite prevalent. Okay, and why are they poisonous? Yeah, it keeps them from being eaten. Okay, and you're going to have some smaller rodent-like mammals. Okay, like this red panda. Okay, yeah, it's pretty cute. And you're going to have some bigger ones. One of the bigger mammals that lives in the rainforest is the sloth. Okay, the three-toed sloth. It's the slowest mammal, right? In fact, they barely can move if you put them on the ground. Okay, they are actually just evolved to move across the branches. Okay, they have, if you've ever seen what their hands look like, okay, their claws or toenails or whatever, they look like coat hangers. Okay, and they can just hang them over a branch like this and kind of shimmy along. Okay, that's what they're more adapted for. If you put them on the ground, their musculature is not designed to bear their weight in a pushing direction. It's designed to bear their weight hanging, and they're almost immobile on the ground. Like they kind of crawl and look like they're sick or injured. Okay, when they're in the tree, they can actually move pretty well.
Why are they so fast in the water?
I don't know, but I've seen them. Yeah, it must be the length of their arms or something. It gives them like good breaststroke action or something. I don't know. Yeah, but they are fairly quick in the water. Okay. Again, probably part of that is their body weight is supported by buoyancy. You put them on dry ground and, right, like for us, our body is actually fairly equally distributed in its ability to push and pull, but not for a sloth. Their pulling ability is very good, but their pushing ability is very bad. Okay. All right. So lots of species are what we call arboreal. Okay. So they live in the trees. You definitely want to live in the trees in the rainforest, especially with all the flooding. Okay. You don't want to be a subterranean animal. Okay. If you like dig a hole and live in it, you're better have scuba gear because it's going to be full of water pretty much all the time. Okay. Okay, and lots of species, including plants in the rainforest, are what we call endemic, which means they only live in that one particular place. So it's very easy to drive a species to extinction by deforestation in the tropical rainforest, because you may be in an area where that's the only place on Earth where that organism lives. Okay, so there has to be a lot of studies done before an area gets harvested. Okay. So that's what we need to know about the animals. Okay, and then chemical cycling. Like we said, the chemical cycling, decomposition, all of that kind of stuff is really, really quick. And that's because high temperatures, high moisture, okay, those things are going to lead to the rapid decomposition and cycling of nutrients in the tropical rainforest. All right, questions on the tropical rainforest? Okay, Savanna. So we're doing the two tropical biomes here first. Okay, so the savanna is a tropical grassland. Okay, so you find them in similar places to tropical rainforest, but what's different is not how much rain they get. The savanna can get just as much rain as the tropical rainforest. It's when they get it. Okay, the tropical rainforest will typically get even precipitation all year long. The savanna has a monsoon season and then a dry season. And the dry season can last 6 to 8 months. Okay, so there's going to be 3 to 4 months where the amount of rainfall is measured in meters. And then there's going to be nothing. Right? So you can't get thick trees and jungle growing if there's going to be long periods of dryness. Okay? That's going to lead to the development of grassy type terrain instead. Okay? So that's why the savanna typically looks more like this, more like what you associate with Central Africa. Okay? You are going to find trees, sometimes even open woodland, but not tropical rainforest type trees. Okay? Trees in the savanna all typically have kind of an umbrella shape. They don't grow overly tall, but they all have an umbrella shape. Okay? The reason for that is in the summertime, sometimes we use an umbrella not for rain, but for shade. Yeah. Okay? If you grow out to the sides, you can shade your roots, which keeps the moisture around your roots there longer. Okay? It also means that if you grow them in this shape, you capture a lot more sunlight, and if you keep your leaves really high, only one animal can eat you. A giraffe. Okay? Okay? Maybe an elephant. Okay? But you obviously have to be very, very tall, okay, to eat any of the foliage off of a tree like this. Right? But we do see that this would be probably right after the monsoon season. You see there's open water, everything is very green, and then later in the year, okay, after the bulk of the dry season, everything is just bleached white, okay, very dry, right? Not a lot of freestanding water anywhere anymore. Okay, so about 12% of the Earth's land area, lots of subtropical regions fringing on the rainforests, okay, and it's referred to as a grassland biome, but a tropical grassland. Okay, the grasses there are going to be a lot different than grasses, okay, not the same kinds of grasses. Okay, so like we were saying, there's a distinct dry season, and lots of plants will estivate. That is, they'll become dormant or go dormant, just like our plants do in the winter, except here they would do it during the dry season. So you can see the climatogram here is showing the same equatorial or tropical temperature trend, but we've got months where we're getting 350 or more millimeters of rain, and then months where we're getting next to nothing. Okay? So we got a long dry season, okay, and then a monsoon season where it just pours rain every day for weeks on end, okay, and then it goes to dry after that. So in those extended dry seasons is, of course, the opportunity for fire. Okay, wildfires are quite prevalent in the savanna, okay, but they do help to cycle nutrients and things like that. Okay, what's this cheetah sitting on? A termite mound. Yeah. Okay. Bugs are also very prevalent in the savanna. Termites being one of the biggest ones. Okay, and they're kind of like a big anthill, really. Okay, you don't want to stir it up, but they will eat anything plant-based. Right? So any plants in the savanna have to produce unbelievable numbers of seeds just to ensure that some of them can germinate and not be eaten. Okay? And termites are that huge, okay, in the savanna, which is also why, again, you don't see a lot of dead trees hanging around. Okay? If a tree is sick, the termites will eat it. Okay? And termites can turn a tree into sawdust in a matter of days. Okay? They are voracious. Okay? We don't worry about termites up here because our winters essentially prevent them from surviving. But in more tropical areas, the construction of homes and buildings, one of the big concerns is keeping termites out. Okay? Because if termites get in your walls, they'll eat your house. Okay? They'll literally eat the frame of your house, and your house will collapse around you. Okay? So they have to be, a lot of construction has to be considered in sealing or treating wood to keep termites away. All right. So vegetation. Many of the trees are fire resistant. For example, the eucalyptus tree. Okay, the eucalyptus tree can actually burn right down. I feel like, well, not right down, but it can be burnt. All the vegetation burnt right off of it. The trunk of it blackened. Okay, and it'll grow back. Its bark is very porous and actually acts as a good insulator. So the sap inside doesn't cook. Okay, when the outside of the tree burns, and so the tree can grow back after a fire. Okay, action of fire, appetite of termites, seeds don't survive as much, so plants have to produce huge amounts of them. Okay, plants also have to be resistant to water loss. They have to maximize their uptake of water during the monsoon season and then be able to store it or go dormant. Okay, deep roots and flattened crowns. Some will shed their leaves during the dry season or estivate. Okay, savanna trees are often stunted, and there are places, like in this picture here, where the grass can be taller trees. Right? I had a student a number of years ago who came from South Africa, and he was telling me about their summer house, vacation house, their cabin. Okay, and that's a picture of it. Exactly. Every time they go there, they have to take they all go out with these big scythes, and they have to cut down the elephant grass because it'll grow higher than the house. Yeah, because when I was teaching this lesson, I was talking about elephant grass. It's like, oh yeah, that stuff's for real, because nobody ever believes me when I say it's called elephant grass because elephants can walk through it and you can't see them. He's like, yeah, it grows taller than my house. And then he sent me a picture of it. Okay? So his house is in there somewhere. Okay? But this elephant grass is like bamboo. Okay? It's thick and tall. Right? So it's actually a really good food source. It's very nutrient rich. So that's why you can get all these really big herds of large herbivores in the savanna. Okay? Because there's lots of grass to eat. Okay? But this stuff can grow really, really tall. Okay? And it can overtop the trees. It can overtop this. Okay? It's not a 3-story house. It's like a bungalow. Okay? But still, it's still impressive. Okay, when we think about how tall that would be. Okay. Now, the soils in the savanna are actually kind of like soils here on the prairie. They're both grasslands. So there's a lot of A-horizon, a lot of topsoil, because every year the grass dies and then new grass grows in its place. So there's always this layer of thatch, dead grass, that's going to decompose and build up that organic material in the A-horizon. So you can see in this soil profile, all we see is A-horizon. It's all topsoil, down to 3 feet. Okay, so there'd be some clay below that, then obviously rock below that. Okay. For the fauna, okay, animal diversity is low. That's different than the tropical rainforest where animal diversity is high. Okay, in the tropical rainforest, a food chain is very, very long, right? Because you start out with your plants, and then you have the bug that eats the plants, and the bug that eats the bug that eats the plants, and the bug that eats the bug that eats the bug that eats the plants, the bug, lots of bugs. Okay, so the food chains are really, really long. Okay, in the savanna, they're incredibly short. Your top carnivore feeds directly on the herbivore. Okay, so you've got your producer, your primary consumer, and then your top carnivore. Okay, just remember the food chains from before. Okay, so they're very, very short. That's just where they end, right? You got lions eating wildebeests, the wildebeests eating the plants, short food chain. Okay, but obviously in the rainforest, the food chains can be much, much longer. Okay, there's lots of scavengers, obviously, in the savanna, because being a buzzard in the savanna works way better than being a buzzard in the jungle, because you can see dead stuff. Right? There's no trees blocking your line of sight. Okay, so you do see a lot more scavengers like hyenas and stuff like that. Okay, that will prey on, well, not prey on, but they'll go and eat the kill after the lions are done with it. Okay. So for chemical cycling in the savanna is still very quick. Okay, I mean compared to up here. You got the monsoon season where you got lots of moisture, you got lots of scavengers, you got lots of bugs. Bugs are really important in getting things to be broken down and made smaller so that bacteria and fungus and stuff can work on them. Okay, so we are looking at obviously a lot quicker decomposition and stuff like that. So this would be an area in the savanna after the monsoon season, so it's just flooded, okay, just water everywhere. And then this would be it during the dry season. Okay, very, very different looking. You can see the trees all have that umbrella shape, that flattened crown that keeps them from being eaten by all of the smaller herbivores there. Okay. You know what? I think we'll leave it there, and I will talk about the deserts when we come back on Monday. So I'm going to go over the rest of the biomes on Monday, and we'll start our chemistry review after that. I will post the unit exam review today, but I'm not going to do our unit exam review until Tuesday.
How do you call